Hi, and welcome to another IFR video. This is the first in a series of videos about IFR holds. In this episode, we will learn about the dimensions of a holding pattern. You probably already know that regulations specify that the inbound leg of a holding pattern must be 1 minute long when holding at or below 14,000 feet, or 1.5 minutes when holding above 14,000. Because the regulations specify time and not distance for the inbound leg, pilots have traditionally held by reference only to watches. But with most modern airplanes equipped with GPS these days, it is my purpose to show you that you can hold much more effectively and easily if you translate the requirements into distance. Let me show you what I mean. There is a fixed relationship between velocity, distance, and time, such that distance equals velocity times time. To use this relationship, the first thing we need to know is our speed. In this video, I'm going to fly a couple of demonstration holds in a light twin at 6,000 feet and 120 knots indicated airspeed. These are quite typical values for many IFR training aircraft. We must realize that even though our indicated speed is 120, our true airspeed is higher. Let's break out the CX2 to get an idea of what our true airspeed is. Entering 120 as the calibrated speed and 3.1 degrees Celsius as the standard temperature and 6,000 as the pressure altitude, we see that true airspeed is 131 knots. For this first video, we will examine the dimensions of a hold in zero wind. I promise we will cover the effect of wind thoroughly in an upcoming episode. So we know that ground speed will be 131 throughout the hold. Therefore, the inbound leg must be 131 times 1/60th of an hour. Run that through your calculator and round off to one decimal, which is all the accuracy we need, and we have 2.2 nautical miles. Now, just knowing this one number is a great help, since it gives us something to shoot for. But to take full advantage of our GPS, we need to know more. As the airplane reaches the outbound leg of a hold, the GPS tells us the cross-track distance. In a zero-wind hold, this cross-track distance will remain constant along the entire length of the outbound leg. What should this value be? Grade 10 math gives us the answer. The diameter of a circle is equal to its circumference divided by pi. The two 180-degree turns of a holding pattern are, of course, just a circle interrupted. And we know it takes 1 minute to fly each turn, or 2 minutes to fly a complete 360. So the circumference of this interrupted circle is equal to our ground speed times 2/60ths of an hour. In our case, that's 4.4 miles, and dividing that by pi, we get 1.4 nautical miles. Once again, I have rounded off to one decimal place. We now have two useful numbers, but one more number will make flying the hold a piece of cake. If we know the diagonal distance across the hold, we will know exactly when to turn inbound without the need to refer to a stopwatch. Grade 10 math to the rescue again. Pythagoras gives us the solution. Run these numbers through your calculator and you will come up with 2.6 nautical miles. I guarantee you that if you turn inbound when your cross-track reads 1.4 and your diagonal distance reads 2.6, you will roll out in the perfect position to get exactly a 1 minute inbound leg. Okay, enough talk. Let's give it a try. Okay, so we're tracking inbound to the Abbotsford Beacon on a track of 067 degrees. We've been cleared to hold west as published. So that published hold is an inbound track of 067, standard hold, right turns. So it's just going to be a direct entry, and there is zero wind, so we'll find out whether the dimensions that we just worked out actually work or not. So right now I have the Abbotsford Beacon on the GPS. I also have the Abbotsford Beacon tuned and identified on the ADF. I have my HSI set to a course of 067. I have the RMI selector in GPS mode, so the green RMI needle is pointing at the Abbotsford Beacon through the GPS. and the yellow needle is always on ADF. So I have the 2 needles on my RMI pointing at the Abbotsford beacon. GPS says I'm 7 miles from the beacon right now, so I'll begin slowing down to 120 knots indicated. And once we're slowed down, we'll check our ground speed and see if it's 131 knots as we predicted. Now I've already switched the GPS to OBS mode, but as I come down to 5 miles from the fix, when you're doing a hold, if you're not already in OBS mode, you would want to switch now. So 5 miles from the station, we're already in OBS mode, speed dropping down through about 127 right now. When we reach the NDB, all we have to do is make a 180-degree turn to the right at a rate 1 to a heading of 247 degrees. So there's 121 knots, we're almost there. And there's 120 knots established, about 3.5 miles back from the NDB. So the way I have the GPS set up, it doesn't show ground speed on nav page 2. I have to switch to nav page 1. So there we are, ground speed 131. Science is amazing. So we know our true airspeed is 131, so that confirms that the wind is indeed calm. And I'm pretty much right on track. 1/100th of a mile off doesn't really count. Uh-oh, 2/100ths of a mile. Better make a correction. So a half mile, we're almost there. And just wait for the 2-front flag to flip on my HSI. There goes the RMI and there goes the flag. So I turn the bug around 180 degrees. And then I roll into the turn. Trying to be as precise as I can. 2 knots slow, so I'll just add a smidge on the power and see if I can correct that. So we roll out on our reciprocal heading. Now we wait for the 2-from flag to flip before we start our outbound time. And I am going to start the outbound time. Oh, there it goes. So I start my stopwatch. So I've taken the time, but to be perfectly honest, I'm not even really going to look at it. It's just a backup. So I check my cross track. And 1.37, as far as I'm concerned, that rounds off to 1.4. So that seems perfectly good to me. And I'm just going to hold this heading now until I get to a diagonal distance of 2.6 miles. In zero wind, that should correspond to 1 minute, but it's not the time that I'm going to go by, it's the distance. So there's just coming up on 2.1 miles. My cross track still steady. There's 2.3 miles. I like to get my heading bug set before I get to 2.6. 2.55, 2.6. We roll into the turn. And I'm sure you noticed that the time was just about exactly 1 minute, so we could have gone by that. But it's more consistently reliable to go by the distance. You'll also find that it's much easier from a workload point of view, especially if you're busy, as you will tend to be in the real-world IFR scenario. You'll probably be busy doing briefings, checklists, all kinds of stuff that tends to distract you. It's a lot easier to go by distance than it is by time. Okay, so it's looking pretty good here. So as I get close and I'm ready to roll out, I like to get my finger ready on the button. Okay, so as I begin to roll out and I hit the button right about there. And if you notice, the distance to the station was exactly 2.2 nautical miles. So I already know this is going to be exactly 1 minute. Now, we'll play it out just so that I can show you that it's a minute. But in all honesty, I already know it's going to be 1 minute. Oops, running a couple of knots fast there. That'll throw it off by a couple of seconds, so I'll just fix that. Okay, so there's just coming up to 50 seconds. And my clock says 1 minute right now, and there's the flip. It doesn't really get any more perfect than that. Okay, so that pretty much confirms that the dimensions of the holding pattern are exactly what we calculated. I'm going to do one more demonstration. This time we'll set up for a non-standard hold with left turns. Okay, we're back, and this time we're tracking inbound to the Watcom VOR on the 230 radial. And we're cleared to hold southwest on the 230 radial at 6,000 feet non-standard, left turns. So this will be another direct entry. Once again, the winds are calm. So I have the Watcom VOR set up as the active waypoint on the GPS. And I also have the Watcom VOR tuned and identified on nav1. And it's also tuned and identified on nav2. I have my HSI set up to a course of 050 degrees. And I have 050 also set on my number 2 VOR. I have my RMI selector on VOR1 or nav1. So the green needle is pointing at the VOR, the yellow needle is still pointing at the Abbotsford beacon. So my GPS shows me just coming down to 7 miles, and the DME matches that. I'll begin slowing now to 120 knots indicated. Now, even though we're supposed to be zero wind, I notice that I'm having to hold 2 or 3 degrees of drift correction here, so I think the simulator really has some phantom wind built in. And that's okay. I might just throw things off a hair here. So we're coming down to 5 miles. I'm already in OBS mode in this case, but if I wasn't, I would switch over to OBS mode now. Okay, another 5 knots to go on the airspeed. And we're just about there at 120 knots, so I fine-tune the power. Oops, a little off the altitude there. 3.5 miles to go. So this time, since it's a non-standard, upon reaching the VOR, I'll make a left turn, 180 degrees, so that'll be a heading of 230 degrees to the left. Just check out our ground speed here. Yeah, still 131, so still shows 0 wind as far as that's concerned. But I'm having to correct just a little bit to the right here to get perfectly on track. Now the GPS is in terminal mode in this case because I'm within 30 miles of my destination airport. You can hold in either terminal mode or en route mode, it doesn't really matter. You may notice I have the map scale set to 10 miles. You may prefer a larger scale or a smaller scale. I notice a lot of students like to zoom in tight, but I don't really see that as particularly helpful in a hold. Okay, we're almost there, half mile to go, waiting for that to from flag to flip on both the HSI and on number 2. There's the RMI turning, and there's the to from flag. So we turn the heading bug around, and then make our rate 1 turn as accurately as we can. Just a little bit slow, just add a bit of power there. Still a little bit slow, add a bit more power. Here we are, rolling out. And we wait for that to from flag to flip. There it goes, we start the timer. Yeah, we check the cross track, 1.36, that's pretty good. I think I'll just turn 3 or 4 degrees to match that mystery drift that we had on the inbound leg. And once again, I'm looking for 2.6 on the diagonal distance. Again, it should correspond to 1 minute outbound, but I'm going to go by the distance. Okay, cross tracks holding nicely up to just coming up to 2.2 on the distance. 2.3, I like to get my bugs set in advance here. And 2.5, and 2.6, and we roll into the turn. Again, it's looking pretty good. We're going to roll out right on track. And get my finger ready on the button here. And as I roll out, start the time right there. And once again, if you noticed, we were exactly at 2.2 on the distance when I started the timer. So once again, I already know for a fact this is going to be a 1 minute inbound leg. So we'll just fly it out to complete the demonstration. But essentially that's the end of part 1 of this series. We've confirmed the dimensions of the hold and zero wind are what we thought they would be. And so in part 2 I'll be back to show you some different entry procedures. And then in part 3, we'll start dealing with wind. Okay, 10 more seconds according to my stopwatch. 5 seconds. And there's a minute, and there's the flip. I don't think it gets much better than that. Okay, I'll see you again in part 2.